Hello, this is going to be a video on fraction operations. And an operation is either addition, subtraction, multiplication, or division. Now, fraction operations really put themselves in two categories that are quite a bit different. First of all, we're going to deal with addition and subtraction. And then later in the video, we're going to deal with multiplication and division. So first, we're beginning with addition and subtraction. In some ways, addition and subtraction are easier to understand, but they really are harder to do. So they're actually the more difficult of the operations. So you may have heard me talk about pizzas before, and if you go to Costco and get a pizza, they usually come in 12 slices. And we know if I had one pizza with, let's say, it was divided up, and I'm not even going to divide it up here, but it was divided up, and I had 7 slices, so 7/12ths of a pizza. And then I had another pizza that was partially eaten, and I had, let's say, 5/12ths of that pizza. Let's not pick 5. Let's pick something like 11/12ths of that pizza. I could add these two together, so most of this pizza's here. I could add these two together by just adding the numerators and keeping the denominator the same. So I would end up with 18/12ths of a pizza, which I could reduce because 6 goes into both of these. So 6 is the GCF. So 18 divided by 6 is 3. And 12 divided by 6 is 2. And we get 3/2 or 1.5 pizzas. Okay, that's with the common denominator. Another example with the common denominator, if I had 3/7 plus 2/7 sevenths, I would have 5/7. The denominator stays the same, I just add the numerators. The problem becomes when I have different size slices. So let's just say I have here, let's say a pizza, and I'm dividing it into 4s. You'll notice that these are meant to look exactly the same. They're probably not exactly the same, but we need to assume they're exactly the same. And I have another pizza here, same size. Yeah, I can only draw it so well, but wholes are always the same size, and fractional parts are always the same. So let's say I have this pizza. I'm going to divide this one up again into 8ths. So here I have, let's say I'm going to shade this in, so I have 3/4 of this. So this is a pizza, and 3/4 of it has not been eaten. This is the cardboard here. And then over here I have, I'm going to go, here's 4/8. Sorry about that. Here's 4/8. And here's 5/8. So I have 5/8. So I'm adding these two. So I have 3/4 of a pizza, and I have plus 5/8 of a pizza. And, I can't go 3 plus 5 is 8, and 4 plus 8 is 12, and say that's it. that sounds nice, but it doesn't make any sense. So what I need to do is have the same size slices of pizza. Well, if I made both these into eighths, I'm going to do that now. The one's already into eighths, but if I make this other one into eighths, now I can count how many eighths it is. It's 1, 2, 3, 4, 5, 6. So this is 6 eighths plus 5 eighths. And now I have the same size slices and I can add them. And so I go 6 plus 5 is 11. Add the numerators, the denominator stays the same. I can make a mixed number, that's an improper fraction. I can make a mixed number out of it. That's basically 11 divided by 8 goes in there once with 3 left over, or 3 eighths. Or I can say 8 goes into 11 one time with 3 left over, so that's 1 and 3 eighths. So I have 1 and 3 eighths pizza. So that makes pretty good sense. And so that's the basic rule, that we need a common denominator. And we usually try to get what we call the least common denominator. Now, if we had to draw pizzas each time, it would be sort of a hassle. So we don't do that. Usually if I had 3/4 plus 5 eighths, I would look at that. I would say the least common denominator is 8. I would go here, I say, well, how do I get, this is already eighths, how do I get 4 to 8? Well, I had to multiply it by 2. If I multiply the bottom by 2, I have to multiply the top by 2. So I get 6 eighths plus 5 eighths is 11 eighths, or as we said before, 1 and 3 eighths. So that's the basic idea about subtracting fractions. Let's try 1 or 2 more here. So let's say I have 3/5 plus 2 eighths. Lowest common denominator, one way I can get a common denominator is always multiply these two, which is the only thing I can do here. So it's actually 40ths. So I have a certain number of 40ths plus a certain number of 40ths. Well, 8 goes into 5 times 8 to get 40 here, so I need to multiply the top by 8, so I get 24 40ths. I needed to multiply this by 5 to get to 40, so I multiply the top by 5. I get 10 40ths, and I get 34 40ths. And that can be reduced to 17 20ths by dividing top and bottom by 2. Other thing I could have done here, I didn't. I could have changed this to 1/4, reduced this, and then I could have got a lower LCD. Okay. Let's try one with, let's say I have 2 thirds plus, actually I'm going to change that. Let's say I have 5/12 plus 3/8. Well, I said one way to get a common denominator is I could multiply these two together. That doesn't make too much sense though. What I want to do is find something that both 12 and 8 can go into. Well, so, and I want the smallest thing possible. Well, let's double 8. That doesn't help us because 12 doesn't go into 16. Let's double 12. Oh, that's 24. Can 8 go into 24? Yes. So both 12 and 8 can go into 24, and that's the smallest thing both of them can go into. So I have 24. And so 5/12 is how many 24s? Well, to get 12 to 24, I multiply by 2, so I need to multiply the top by 2 also. So I get 10 24s. And 3/8, well, to get from 8 to 24, I need to multiply it by 3. And then I need to multiply the top by 3, and I get this, and I get 19 24s. Can't reduce that, so I'm all set. Okay, let's do subtraction. Subtraction's pretty much the same. Let's say I have, well, matter of fact, let's do something similar. 5/8 minus 3/12. Again, we know we need a common denominator. We know from above the common denominator is 24ths. So I'm going to make 24ths out of both of these. To go from 8 to 24, I multiply by 3. I need to multiply the top by 3 also. So 5 times 3 is 15. This I need to multiply by 2 to get from 12 to 24. So I need to multiply the top by 2. And I get this by 2. And I get 6. And I get 15 24ths minus 6 24ths is 9. No, not 9. Is, yes, 9 24ths. Can that be reduced? Yes. Divide top and bottom by 3. And I get 3/8. Notice I could have reduced this to 1/4 over here if I wanted to, too. Now, I'm going to now look at the idea of mixed numbers, in adding and subtracting mixed numbers. With mixed numbers, you can do the whole numbers and fractions separately. You wouldn't necessarily have to do that. The other approach would be to make them both into improper fractions, but it often makes a lot of sense to do them separately. So let's say I have 3 and 5/9 plus 2 and 1/4. Well, what I can do is do the 3 plus 2 first, so that's my first step. 3 plus 2 is equal to 5. My second step is do the fractions, so that's 5/9 plus 1/4. And my common denominator, let's see, if I multiply them together, it would be 36. I don't think I'm going to get anything lower than that. So it's 36. And so, oops, I'm sorry, go down there. Multiply this by 4, multiply this by 4, and I get 36. Plus, multiply this by 9 to get to 36. So I need to multiply the top by 9, and I get 9. So 36 plus 36 is 36. There. Now, third step is to combine the 5 and this. So it's 5 plus 36, and so my final answer is 5 and 36. Well, let's look at other one and see some other things that might happen. Let's say I have 2 and 2/3 plus 1 and 3/4. First step, add the 2 and the 1, and I get 3. And then I'm going to do the 2/3 and 3/4. I'm going to make those into 12ths. So this should be 2/3 is, multiply that by 4, multiply that by 4 is 8/12, plus multiply by 2 is 6/12, and 8 plus 6 is 14/12. Let's see, 4, 8, and 3/4. I'm sorry, 3/4. This should be 3 and 3. My mistake. 9. Sorry, 17/12. So this is 17/12, and so we have 1 and 5/12. Now we combine these. I have my 3 plus 1 and 5/12. I have 4 and 5/12. Basically, I'm adding these two. Hopefully that makes sense. I made a little mistake there, but it didn't look right to me, so I went and corrected it. Okay? Okay, let's do mixed numbers now with subtraction. So let's say I have here 3 and 3/4 minus 1 and 1/2. 3 minus 1 is 2. 3/4 minus 1/2. And need a common denominator, so that's 3/4 minus 2/4, and that is going to be 1/4. I combine these two. I have 2 plus 1/4, and I have 2 and 1/4. I'm going to do a little bit different one now, which is a little trickier. Let's say I have 3 1/2 minus 1 3/4. Well, I look at this one now, and I have, I can go 3 minus 1, but when I look at this next step, it's going to be 1/2 minus 3/4. Unless I'm like in pre-algebra, I don't know how to do that yet because I haven't had negative numbers. And so I'm supposing in this video you're more like a 5th grade level. And so we don't know how to do that. So what we're going to do is we need to sort of rename this so that we don't, so we have a bigger fraction here subtracting a smaller fraction. So the way I could rename this is I could sort of regroup here. I could call this 2 plus 2/2, right? Because 3 is the same as 2 plus 1, or 2/2, plus my 1/2 here. And so I could rename this 3 and 1/2 as 2 and add these together, 3/2. So 3 and 1/2 is the same as 2 and 3/2. And then I subtract my 1 and 3/4. I probably could have gotten a common denominator first, probably would have made sense, but I won't worry about it here. So now I have 2, and I'm going to get my common denominator here. It's going to be fourths, right? So I'm going to multiply by 2, multiply by 2. 2 and 6/4 minus 1 and 3/4. This looks pretty easy now. 2 minus 1 is 1. 6/4 minus 3/4. Denominator stays the same. Subtract the numerators. 6 minus 3 is 3. And I'm basically adding these, combining these, 1 plus 3/4. And my final answer is 1 and 3/4. I always say add here because when you get into pre-algebra, you really are adding, because when you get into pre-algebra, you can do things with positive and negative numbers here, and it's important to remember that. You know, with that, you know everything about the most difficult part of fraction operation, and that's adding and subtracting fractions. Now we're going to go to multiplication and division. Multiplication and division is quite a bit different. Let's talk a little bit about what multiplication is first. When we say, let's say I have 1/2 of, let's say, 6. You know, that makes sense. 1/2 of 6. It's a multiplication problem. Of means multiplication. 1/2 of 6 is equal to 3. Okay? And that's what multiplication means, really. It's, 1/2 of 6. So it makes sense there. Let's look at what we really do there. If that's multiplication, well, it's times 6, put that over 1. Really all we're doing is multiplying across. 1 times 6 is 6. 2 times 1 is 2. 6 over 2 is 3. That's the rule for multiplication. Multiplication, you multiply across. Okay, so let's say I have 3/5 times 2/9. 3 times 2 is 6. 5 times 9 is 45. I can go ahead and reduce that because both these are divisible by 3. 6 divided by 3 is 2. 45 divided by 3 happens to be 15, so it's 2/15. I'm going to show you another little trick you can do, which is illustrated by that one. If I have 3/5 times 2/9, well, basically at this point, I have some common factors here. This is 3. This is effectively 3 times 3. I can do something called cross-cancel. Cross-cancel just basically means I have common factors above and below, and I can cancel any common factors. I can go here that 3 goes into 3 once, and 3 goes into 3 goes into 9 3 times. And then I get 1 times 2 is 2, and 5 times 3 is 15. Cross-canceling like that is going to save you a lot of work. So don't view it as another complication. View it as a time saver. Now, if we have mixed numbers, a really firm rule you need to remember. Mixed numbers, you must change to improper fractions. If you try to do the whole numbers and fractions separately and just sort of combine them, you're going to get a decent looking answer and it's going to be wrong. So don't do that. You have to do this. So let's say I have 2 2/3. And let's say I'm multiplying it by 1 3/4. I have to do this. I have to change this to improper fraction. We know how to do that. 3 times 2 is 6, plus 2 is 8/3. Or we can think as 2 is 6/3. 6/3 plus 2/3 is 8/3. Change this. 4 times 1 is 4, plus 3 is 7. 7/4. Or we can think of the 1 as 4/4. 4/4 plus 3/4 is 7/4. I could just multiply across now. I see an opportunity to cross-cancel here. 4 is a factor here, it goes in once. 4 is a factor here, it goes in twice. Now I can multiply across and I get 14/3. 3 goes into 14 4 times with 2 left over. So it's a mixed number that is 4 2/3. If they give it to you in mixed numbers, you should give it back to them in mixed numbers. We can look at the reasonableness of this. I have something that's a little bit, well, close to 3 times something a little less than 2. And so it's 4 and something. It's a pretty reasonable amount to expect. Okay? But you must do this with multiplication. You also have to do it with division. Let's look at division now. That's our last operation. And so with division, let's think a little bit about what division is, first of all. If I have, let's say 3 divided by 1/2. Well, this is asking how many 1/2s are in 3. So let's say I have a candy bar and then another candy bar. So these candy bars are supposed to be the same size, although they don't look too much like it. Well, how many 1/2s are in there? These are the wholes. These are the 1/2s. There's 6 1/2s in 3. And so the answer to this problem is 6. We could spend more time on this, but for the purpose of this video, I'm going to shorten things and say, well, if you look at this, that is like taking this 3 divided by 1/2. It's like taking 3 and multiplying it by the inverse of 1/2. The multiplicative inverse of 1/2 is 2 over 1, or simply 2. I'll put 2 over 1. I'll put the 3 over 1, and I get 6. So this leads to the rule that we discussed more in class, that to divide fractions, you multiply by the reciprocal of the second fraction. The reciprocal means this, the reciprocal means you flip it. So let's say I had a fraction 3/4. The reciprocal is 4/3. So that's what reciprocal means. You just flip it. It's a second fraction only. So let's do a bunch of examples with this, or at least a couple. Let's say I have 3/4 times 2, not times, divided by 2/3. Well, first of all, you might think, wow, okay, I remember that cross-canceling. Let's go ahead and do that. You can only cross-cancel when it's multiplication. It's not multiplication yet, it's division. But I'm going to make this multiplication because this whole thing is equal to 3/4 times inverse of 2/3. Multiplicative inverse, or the reciprocal of 2/3, is 3 over 2. If I could cross-cancel, I could do it now, but there's no cross-canceling available. Okay? So I just multiply across. 3 times 3 is 9. 4 times 2 is 8. That's an improper fraction. I'm going to make it into a mixed number. 8 goes into there once with 1 left over. I have 1 and 1/8. Let's try another one. 3 fifths divided by 1/4. That's basically asking how many 1/4 are in 3/5. We're going to go 3/5 times, and flip this, in other words, do the reciprocal, times by the reciprocal of the second number. 1/4 is 4 over 1. 3 times 4 is 12, times 5, and we can make this into a mixed number, and we get 2 and 2/5. 5 goes in here twice with 2 left over. Okay. Division's just like multiplication when you have mixed numbers. So mixed numbers and division, you must convert the mixed numbers into improper fractions. So let's say, for example, I have 2 and 3/4 divided by 1 1/2. Well, 4 times 2 is 8 plus 3, that's 11/4. Divided by 2 times 1 is 2, plus 1 is 3/2. Okay, now I go multiply by the reciprocal of the second number, so times 2/3. Okay, I do have some opportunity for canceling here. 2 goes into 2 once, 2 goes into 4 twice. Multiply across now. 11 times 1 is 11. 2 times 3 is 6, so we have 11/6, or that's 1 and 5/6. Okay, and that's it. So that's a summary of how you do operations with fractions. The most important thing is to remember that with addition and subtraction, you have to have a common denominator. Also, with addition and subtraction, with mixed numbers, you could do the whole numbers and fractions separately. Now, with multiplication and division, it's actually easier. You do not need a common denominator, and there's no reason to get a common denominator. So you just multiply across, as you may recall here. We just multiply across for multiplication. Sorry, we multiply across for multiplication. For mixed numbers with multiplication, you must change them to improper fractions. And then back to division. For division, you multiply by the reciprocal of the second fraction. And the reciprocal just means you flip it. And again, with mixed numbers, as with multiplication, you must convert them first to improper fractions, and then you multiply by the reciprocal of the second number. Okay, with that, I will end this video. And let me just get rid of this.